Okay, so welcome to this video that involves trigonometry and surds. You can see we have sine of 75 and we have square root of 6 plus square root of 2 over 4. And the question says simplify that. So we can begin by taking sine of 75 degrees as square root of 6, the way we are given. And then we take the reciprocal of that. So the reciprocal of sine of 75 is equals to 1 over sine of 75 degrees. And so the reciprocal of this number here is going to be equal to 4 over square root of 6 plus square root of 2. So it goes without saying that 1 over sine of 75 degrees is equals to 4 over square root of 6 plus square root of 2. All right? And the point of having this question is to learn how to simplify what we have in the denominator here, because we have some surds. How do we get rid of that? We can get rid of this square root of 6 and square root of 2 in the denominator by multiplying by a conjugate. So the conjugate of that is square root of 6 minus square root of 2. So you multiply that both in the numerator and denominator. So when you do that, you're going to have 4 into square root of 6 minus square root of 2. That is numerator, and denominator we have difference of squares again. So we take 6 minus 2. And so we have 4 into square root of 6 minus square root of 2 over 4. And this one cancels, so you have square root of 6 minus square root of 2. That checks. So our answer is 1 over sine of 75 degrees is equals to square root of 6 minus square root of 2. Okay, maybe we can do another question which is a bit tricky. Given that, giving you the second question as a bonus here, given that tan of 75 degrees is equals to 2 plus square root of 3, okay, actually this is a bonus, find tan of 15 degrees. Okay, so this one is a bit tricky. I think we should actually separate these two. So to do this one, you need to rely on the principle that actually says that tan of theta is equals to 1 over tan of 90 minus the same theta, right? So this is a very important principle. You should always maintain that. So you can see if we say that our theta is 75, then 90 minus theta will be 15 degrees. And that happens to be what we are looking for. And so we're only going to play around with 2 plus square root of 3, having been given us tan of 75. And we try to see whether we will come up with the answer both in surd form, just like the way we've given 2 plus square root of 3 here, as now the answer to this tan of 15 degrees. Right, so we can say tan of 15 degrees, we've seen it's a reciprocal of what we have here. So we can say it is 2 plus square root of 3. So 1 over that is tan of 15. We can't leave it in this form. We need to simplify that further. And what we are going to do is to multiply by a conjugate. So the conjugate, perfect conjugate of this one is 2 minus square root of 3. And we do that both in the numerator and denominator. And you notice this one is very simple because the numerator remains like that. And then denominator, we have difference of squares again. And that is the powerful aspect of the conjugate, because when you multiply by a conjugate, you get rid of the surds in the denominator. So you can say 2 squared is a 4, and square root of 3 squared is a 3, and this gives me 2 minus square root of 3 over 1, and that's the answer. And by the way, we can confirm that if you're given tan of 75, actually it's something to do with 3.732050808, which is like 2 plus square root of 3, because square root of 3 is 1.732, right? So adding to 2, it gives us what we have actually found as the answer to tan of 75. So when you take tan of 15, so I'm just confirming so that you can see tan of 15 is 0.267949192, which is also equal to 2 minus square root of 3. That checks. So it means that tan of 15, which is 1 over 2 plus square root of 3, actually the reciprocal of this one, can be written in a very nice way as 2 minus square root of 3. And that is how it is done. Thank you.